Hello and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 828, count unique characters of all substrings of a given string. Let's define a function, count unique characters, s, which returns the number of unique characters in s. For example, calling count unique characters on s, if s equals to Leetcode, then L, T, C, O, D are the unique characters since they appear only once in s. Therefore, count unique characters equals 5. Given a string s, return the sum of count unique characters t, where t is a substring of s, and the test cases are generated such that the answer will fit in a 32-bit integer. And you'll notice that some substrings can be repeated, so you'll have to count the repeated ones too. Let's look at a basic example, ABC. And let's enumerate all of the possible substrings we can have, right? We could have A. We could have AB, we could have ABC, we could have B on its own, we could have C on its own, we could have, we could have BC, right? Those are all of the possible substrings we can have. Now, what are their lengths, right? So A has a length of 1, B has a length of 1, C has a length of 1, obviously AB has a length of 2, ABC has a length of 3, and BC has a length of 2. So if we add all this up, 1 plus 1 plus 1, that's 3, plus 2, 5, plus 3, 8, plus 2, 10. So we would return 10 here. The problem is, this question is really easy if you look at it and you want to draw all this out, and the naive solution would be to just generate all the possible substrings and take their lengths. The problem with that is that when your string's really big, that's going to be a really inefficient solution. So what we want to do is we want to somehow do this in one pass if we can, in some sort of like a greedy manner. And that's what we're going to do. Though I will warn you, the solution is a little bit tricky to wrap your head around. So what we're going to do is we're going to walk through an example, and hopefully it will help you kind of wrap your head around it. Although the intuition behind it, it may take some kind of thinking to see why it works. But what we want to do now, I'm going to wipe all of this away, and we're going to look at a little bit better of an example and actually walk through how the solution is going to look, because it is quite complex, and I really doubt that you're going to come up with this on your own. So let's now wipe all this away and think about our actual solution. So we talked about the naive solution, but that wasn't good enough. What we want to do now is go over the actual solution. So we're going to need a few variables here to actually help us. And if I could just get my pen back. So the first one, obviously, we're going to have to keep track of a result, which in the beginning is going to be 0 because we haven't counted anything. We're also going to want to keep track of the current count, basically the length of our current substring that we can form, and that's going to be 0 as well. What we want to do now is, because there can be duplicates in a string, this poses a bit of a problem for us because we don't want to be double counting things in the case that there's duplicates, right? Like in this string, we cannot form the substring ABCB, right? Because then we'll have two B's and that's no longer unique. So when we see that second B, we have to be careful not to actually double count things in our substring that we can form. And we have to only basically form substrings from the last time we saw a B, because only that part will be unique. So when we see the second B, we can form the substring C and CB. We can't form ABCB, we can't form BCB, because those have two B's, and obviously that's not unique. So every time we see a repeated character, we actually need to only consider substrings from the right of whatever that last character was. And for this reason, we're going to have two dictionaries, or we can just have one actually. So we'll have a dictionary, and we'll call this D, which maps for each character. It's going to map to a list, and what that list is going to have is the last seen index for that character, and then we also want the the last before the last, so the second to last, right? So second to last, and we're going to store this. And in the beginning, all of this will be initialized to -1, -1. And you'll see why we need to do this in a second. Basically, this is just to handle the edge case when you actually see a character for the first time. We want to be counting it properly. So that is the general setup that we want to have here. So let's just remove all this stuff for our D so we can have an empty dictionary. And let's actually go through this line by line. So what we're going to do is we're going to go over our string from left to right. And we're going to get the current index and the current character. So let's kind of just separate this. So the current index is obviously 0, and our current character is A. So when we have A, obviously the only substring we can form is A, right? So the length of our current substring is going to follow this formula. So we're going to add to whatever the length, our current length is. We're going to do this. We're going to say whatever I is, so our current index, minus the last time that we saw, you know, our I, right? So we want to basically, okay, so what is it in here? So we don't have anything. So we would initialize our key for A here to basically be -1, because that's the default value. So we're going to say our length is I, which is 0. Actually, let's replace that. No, I'm going to lose all this. Whatever, it's fine. We're going to say 0, and then we're going to put A in here. So A, and this is -1, you'll see why we do this in a second. So we do 0 minus -1, because that's the last time we saw it, is at the -1 index. And this is actually that edge case we're talking about, when you actually just have one character. And now we need to subtract basically the amount of substrings between the last time we saw it and the previous time we saw it, because we, again, don't want to be double counting things, because that won't be allowed. So we would essentially say -1. So we take whatever the previous index was that we saw it at, and we're going to subtract from this the second to last time we saw it. So obviously this is -1. The double negatives will cancel out here. So this is -1 plus 1. So this is actually just 0. And then this is just the double negatives will cancel out. So we're going to essentially add to our current 1, right? So current now becomes 1, which makes sense, right? The length of our substring is 1. Okay, we can kind of sanity check that. Now what we want to do is we want to update our values in, you know, our dictionary here. So the second to last value now becomes whatever the last value was, because we've now seen the character. So we can actually rewrite this, and we can also update the last seen. So the last time we saw A was at 0, and obviously the last time we saw it before that was at -1, because we haven't actually seen it before. Now what we need to do is we need to just simply add to our result whatever the length of the substring is, which is 1. So our result now becomes 1. And then we move on to the next character. So now we're going to be at index 1, and this is going to be B, right? So now we're going to do the same thing. We're going to say we're going to add to our current substring length. So obviously with B, the substrings we can form are A, B, or just B. So in total, we want to add 1 character plus 2 characters plus 1. So let's kind of sanity check that we'll get that at the end here. So in total, we should get 4 after this step. So what do we want to do? So we want to take our current index, which is 1. We want to subtract the last time we saw a B. We haven't seen a B, so it's just going to be at -1. And then we also want to account for the fact that there could be, you know, the previous B. So we're going to take the last time we saw B minus the time before that. But since it's just -1, this should still be 0. And then here we will have 1 minus 1. So this is going to be 2. So we want to add to our current and make it 2. So remember, current was 1 before. So we want to basically you know, account for these 2 substrings. Now, the length right here. So once we add 2 to it, this will become 3. So 3, and then remember, we're going to update our dictionary. So B, when was the last time we saw B? We saw it at index 1, and the one time before that, we haven't actually seen it, so it's still going to be -1. And remember, we want to add to our result the 3 that current equals now, right? That's the length of our current substring. So we're going to add 3 to our result, and now it's 4, right? And we can sanity check this because this is what we established in the beginning. So we're on the right track. Now what we want to do is we get to index 2 and C. Again, we're going to do the same thing. So the current value plus equals, and we're going to do the current index, which is 2. When was the last time we saw a C? We haven't seen a C. So we do -1. And we want to subtract from this the last time we saw a C, and then the time before that. So again, we haven't seen a C yet, so this will cancel out. And this equals 3. And then let's just sanity check again. So at C, what are the substrings we can form, right? We can form A, we can form B, C. we can do BC, or we can do ABC, right? And the total length here is going to be 3, 2, 1, 1, 1, right? Hopefully we haven't missed anything there, but I think that is all of them, right? Let's see. Actually, did we miss anything? Let me try to think. No, I think we're okay. ABC, BC, ABC. So this is 5 plus 8, right? So we should have 8 at the end of this step. Actually, hold up. I think we may have missed one. Let me double check. Oh, I forgot AB. Whoops. Whoops. Yeah, AB. So yeah, it should be 10. My bad. Yeah, I was thinking back to the example. Yeah, so we should have 10 at the end of this step. So obviously this is going to evaluate to 3. So we're going to add to our current 3. So now the current length will be 6. And then remember, we need to update our dictionary. So we haven't seen C yet. So we first seen it at 2, and the last time we saw it was at -1 because we haven't saw it. Now remember, we want to add to our result whatever current is. So that's 6. So we're going to add to our result 6, and it now becomes 10. So we're on the right track because our results are matching. So we can kind of sanity check that this algorithm is actually working. Now what we're going to do is we're going to get to an interesting part, which is when we see our second B, because this throws a spanner in the works, right? So we get to 3B. Now let's think about this, right? We can't form a string like A, B, C, B because there's 2 B's here, which means that that doesn't work, right? So what are the possible substrings that we can do? Well, we could do CB is 1, or we could just do B on its own. So that is a total of 3, right? And if we were to add it to our, previous one, we should, basically end up with 13, right? So what we need to do now is we need to count this without accidentally double counting all of the substrings that we've already formed, because we cannot actually access any of these because they're locked behind the fact that we've already seen a B, right? We can only access things to the right of this previous B. And build substrings from there. We can't actually do anything there, so we need to make sure that we don't double count things that we've already seen. And that's the reason why we're keeping track of these values in terms of like when was the last time we saw a value and the previous time. So let's look at how this works. So now we have B, right? So we'll go through the formula again. Cur, and then we're going to add to current. So what is our current index? 3. Now, when was the last time we saw a B? Last time we saw a B was at 1, right? So what we're going to do here is we're going to subtract 1 from our 3 here. And now what we need to do is we need to say, okay, when was the last time that we, essentially saw a 1 here, right? So we saw one at 1, and then we want to subtract a -1 from this. So what we want to do here, okay, sorry, my recorder cut out there. Essentially where we were at, we were doing this formula. So this is going to be 2 and then minus, so 1 minus 1, this is 2. And this actually gives us 0. Now, why is this significant? Well, let's think about all of the, the substrings that we could build here, right? We could build A, B, C, B. We could build B, C, B. Oops. B, C, B. We could build CB, and we could build B. Now, we can't count the entirety of this substring or this substring, right? Because we only want the unique characters, which means that we can only count AB as 2. And we can only count this one as 1 because it only has that C that we can count. This CB we can count as 2. So CB, that's 2. And then this B, which is just 1, right? So if we were to do this, it's actually 6, which is what our current is currently at. So we don't actually want to count anything new here. So we simply append to our result, which is currently 10. It now becomes 16. So let's, again, sanity check this to make sure that we are correct here. So let's okay, we'll just wipe away some stuff. So let's build all of the substrings we can do. So remember, we are so far at A, B, C, B, right? So we have A, we have AB, we have ABC, we have ABCB, and then we have B, we have BC, we have C, we have CB, we have BCB, and do we have anything else here? Let's see. Then we have a B on its own again, and then I think that is it. Yeah, that should be it. Okay, so let's add all of these. So obviously A has 1 unique character, AB has 2 unique characters, ABC has 3, ABCB has A and C. We cannot count the B's, so this is 2. B has 1, this has 2, this has 1, this has 2, this has 1 unique character, the C, and 1 here. So 1 plus 2, 3, plus 3, 6, plus 2, 8, plus 1, 9, plus 2, 11, plus 1, 12, plus 2, 14, and then plus 1 equals 16. So we are still okay because our result is, as we saw, we added current, our 6 to 10. So we are still on track because our result is right. So now what we want to do is let's now kind of clear things away because we want to make some room here. And okay, so we know that current is still 6 and our result is now 16. So the last thing we need to do is, remember, we need to do 4b, which is that last character. So again, we're going to say current plus equals 2. So the current index is 4. When was the last time that we saw a b? So actually we need to update this from the last time. So the last time we saw a b was actually at 3, and the time before that was at a 1. So we want to say 4 minus, when was the last time we saw it? We saw it at 3. And we want to subtract from this. So we want to take the last time we saw a b, 3, minus, when was the last time we saw, the time before that, a 1, right? So this is going to be 2, and this is going to be, let's see, this is going to be 1. So 1 minus 2 is obviously negative 1. So we want to update our dictionary as well. Even though this is the last key, we don't technically have to do this, but for good measure, it's now 4, 3. And then we want to add to our result minus 1, right? So current, we're going to subtract 1 from current. So current now becomes 5. And we're going to add to our result a 5. So we would get 21 here, which is actually going to be our final result. Now, let's do one final sanity check because this is a little bit complicated and you may not believe me that this works. So our substring is our string is A, B, C, B, B. So what are all the possible substrings here? Hopefully I actually managed to enumerate all of them, but we have A, we have AB, we have A, B, C, we have A, B, C, B, we have A, B, C, B, B. We then have B on its own. We have BC, we have BCB, we have BCBB, and then we have C on its own, we have CB, we have CBB, then we have B on its own again, or we can have BB, and then we have B on its own. Okay, so let's count all these. So obviously A only has 1 unique character, AB has 2 unique characters, ABC has 3 unique characters, ABCCB only has A and C as unique characters, so that's 2. ABCBB, we only have, again, A and C, so we can only count those 2. B is 1, BC is 2, BCB is just the 1 from the C, BCBB is just the 1 from the C, then we have the C on its own, which is 1, CB, which is 2, CBB, which is 1 again, 1 here, this is 0, and this is 1. So 1 plus 2, 3, plus 3, 6, plus 2, 8, plus 2, 10, plus 1, 11, 13, 14, 15, 16, 17, 18, 19, 20. And okay, did I forget one somewhere? Let's see. I probably did. Let's see. Did I forget one somewhere? Okay, I'm off by 1 somewhere. But where exactly is that? I don't know. Let's see. A1, so this is 2, so that's 3, 6, 2, this is 2, so it's 10, 11, 13, 14, 15, 16, 18, 19, 20, 21. Okay, yeah, I miscounted. Okay, yeah, so we're still at 21, and that's our final answer. So quite complicated, but you can see that it works. Essentially, we just want to make sure that we're not double counting things. So we're just keeping track of kind of what the current length is and using that to help us. So hopefully that kind of makes it clear, walking you through the kind of line by line. Now let's actually go to the code editor and type this up. It's really easier to code than it is to explain, which is unfortunate. So we're back in the code editor. Let's write the code. Remember that we need a current variable and our result, which are both going to be 0. And we also need our position dictionary, which is going to be a map for each character, the last index we've seen it, and the index before that. So we're going to say collections.defaultDict, and we want to initialize this with a -1 if we haven't seen the key before. So we're going to say for I char in enumerate s. What we want to do here is, remember, we do current plus equals to I minus what? We're going to say position dictionary of our character, right? Char. And remember that we want to access the last time we've seen it. So this should be what? This should be the 0th index. And then we want to subtract from the last time we saw it. So we're going to say position dictionary of our character of the last time we saw it minus the position dictionary of the character for the time before that. And then we want to update our positions. So we are essentially going to say position dictionary of char of 1 is going to equal to whatever the current last time we saw it was. So position dict of char 0. And then we're also going to say that position dictionary of char for the 0th is whatever our current index is. And then we want to say res plus equals to whatever cur is. And then we simply return res at the end. So what I want to do now is I'm going to submit this, make sure that it actually works. So accepted, cool. I want to talk about the time and space complexity, and then we will kind of do a little bit of an explanation for this formula here, because it can be confusing. We know that it works because we draw it, obviously it's accepted, and we went through a dry run, so we know how it works and that we get the right answer with it, but how we actually derived it is a bit unclear. So let's first do the time and space complexity. Obviously, all we're doing is going over our characters from left to right in the string, and we do a few lookups in a dictionary, which is basically constant time. So it's just going to be a big O of n in the time. For the space, we have this position dictionary, so that's going to be dependent on basically the number of unique characters in S, so it's just going to be big O of n. Actually here, let's see. Let me just double check this. Let's see. What is our... Okay, so since S actually consists of only uppercase English characters, the maximum amount we're going to store in our position dictionary is actually just going to be 26, which means that we just have big O of 1 here for the space complexity, because the maximum we can store is actually 26 keys. And because we know that up front, it's actually big O of 1, even though it may not seem like it because it's only 26 keys and we know that up front. Yeah, it's big O of 1. So now that we have that out of the way, I think that what I want to just talk about is why we use this kind of formula. So what we are essentially doing here is, let's think about what happens when we add a new character, right? We get like A, B, C, B. We want how many new characters is this going to contribute, right? How many unique characters? It's not going to be this entire array or this entire substring, because we've already seen a B, which means that we cannot count B before, right? We cannot count it. So we need to account for basically all of the B's that we've already seen, because we don't want to count them again. So it's essentially going to contribute how many unique characters? Well, it's going to contribute how many are between C and B, right? So the index where we see B now is going to be what? At the 3rd index, so index 3. When was the last time we saw a B? We saw it at index 1. So that means that this is going to contribute 2 unique characters. And how is that so? Well, we could have C, or we could have CB, or we could have, or we could have B, right? No. So my recorder cut out again, but essentially, let's now think about how this works. So remember the string ABCB, right? When we see this second B, what happens, right? That means that when we have a substring, because before we could have a substring like ABC, if we're to add to the B to it, unfortunately, this now gets rid of the B that we could actually count in that substring, because now we've reduced our character by basically the number of B's we have between them, right? Which is 2, and now we'd only get A and C, whereas before we had ABC, which was 3. So what we're doing here is, remember, we see the B at index 3. So everything after the last B is now unique, right? So we could have CB, C, and B, right? Those are our new unique characters that we can get. So we want to take count of that, right? So we want to say that 3, and when was the last time we saw B? Well, we saw it at index 1. So the new unique counts we can get is going to be, the CB, which is 2. Right? So this is 2, but we also have to account for the fact that now that we added a B, we're also going to lose unique counts from previous substrings. So we need to account for that, and this is what this part is, right? So when did we see previously that, B? So we saw it at 1, and when was the previous time? Well, there's not a previous time before this one, so it's still going to be -1, so -1 here. So this, obviously, the negatives cancel out, and this becomes a 2. This is also a 2. So adding this B is actually not really adding any characters at its current iteration. So remember, we still have some new characters. Like, we still have substrings that can be formed, right? We still, now that we added the second B, we can still make BCB, we can still make ABCB, we can still make CB. But with BCB, right, we only get 1 character here. We only get now 2 characters here, and now we only get, CB from this one. So essentially, we're trying to discount from previous counts that we've done characters now that we've added a second one, because obviously we can only count whatever the unique ones are. So it's just the AC. So this basically attempts to do that. And yeah, it's still confusing. Even I get it. It's very difficult to wrap your head around. I would say this is definitely a hard question. Even though the code doesn't look that complicated, actually explaining it is quite hard. I think I've done the best that I can. I mean, I walked you through it. It makes sense on paper, but explaining it, I think, I don't know, hopefully you watch this video and have some sort of epiphany. But this is, the solution you want to go with. Anyway, yeah, kind of ending on a cliffhanger there. This is definitely one of the harder hards, just because of how ridiculous it is to wrap your head around its algorithm. People who come up with this, I have no idea. So yeah. Yeah, there you go. That's count unique characters of all substrings of a given string. Geez, that's a mouthful, but hopefully you enjoyed the video. Hopefully it helped. I think definitely one to kind of just steer you on the right path, and then maybe you can kind of connect the dots on how to actually explain it very well. I think if anything, this is the part that kind of trips me up a bit. I understand it, but it's kind of the part where you're running with the current and how it carries over to the next iteration is still a little bit unclear for me. So yeah, anyway, if you enjoyed the video, like and comment. If you want to see more content like this, I promise my other explanations are much better. This is a very, very hard problem. I did my best on this one, not gonna lie. And yeah, thanks for watching, and I'll see you in the next one.